Swayam Prabha. Digital India. Educated India.
Hi dear friends, welcome to this fifth lecture of Module 7 on effect of geological structure on stability of dam foundation and tunnels. In previous discussions, we have studied about the effect of fold, fault, joints and unconformities on stability aspects of dams. Now in this lecture, we will discuss about the effect of geological structure, particularly fold, faults, beddings, schistosity, lineation, joints, unconformity, etc. on possibilities of ground control problems in tunnels. In this lecture, we are going to learn about the effect of bedding, folds, faults, joints and unconformity on ground control aspects of tunnels. Regarding this, we are going to cover about introductory aspects, then major structures affecting the ground control aspects of tunnel like folds, faults, bedding, schistosity, lineations, foliations, joint, unconformities. Friends, as you know, the fold, faults, joints, unconformities, fractures, cracks are generally inherited in geological ground. These structures commonly present in geological ground. If we are going to drive tunnels in such ground, then these geological structures are acting as supportive way or disturbing way. Or in another word, we can say that favorable and unfavorable responses on the ground control aspects of tunnels. Due to adverse effect of geological structures, the tunnels requires costly treatments, complicated, advanced and costly support system to encounter the problem concerned with effect of these geological structures. Hence, the cost of treatment as well as the technical uncertainties we are going to face during development of tunnels. First, we are going to discuss about the effect of folds on tunnel lining. Generally, we have two types of folds, anticline and syncline. Although there are many types of folds, syncline, anticline, homocline, recommend folds, chevron folds, cylindrical folds, etc. But in major shape we are going to encounter anticline and syncline. If the tunnel passes through an anticline like this, then the tunnel is under intense lateral pressure. intense lateral pressure tunnel is experiencing because the fold is formed due to compression of strata. Due to this, there is a development of number of discontinuities. If this discontinuities is going to contact or exposed on the surface, then there is a problem. So first we are going to see about the stress condition. If the tunnel is under intense lateral pressure or stress, if it is driven through an anticline at the portal problem, here this portal side we are feeling intense lateral pressure with fold axis aligned nearly parallel to the tunnel axis. This fold axis aligned parallel to the tunnel axis. In such situation, this tunnel excavated in anticline experience intense lateral stress or intense lateral pressure. However, we have already discussed due to bending effect. Here we are going to see due to compression this whole strata is under bending, so this portion is under tension and this portion is under compression, and in this we are having some lateral zone, no compression, no tension. Due to tension there is a development of number of discontinuities or joints or fractures. If this fracture is going to intersect the surface, then there is a problem. Then there is a problem of flow of surface water other as fall out of this zone. So therefore the tunnel should be driven in a deeper to avoid high frequency of joint, and the problem of this rock fall and water drainage can be minimized in this way. When the tunnel passes through syncline, although the rock type of the anticlines lying at the top is competent enough, but due to traverse of joints in case of anticlines going to make some rock mass weaker in nature, and due to weaker in nature there is a possibility for the fall of material inside this. However, in case of the tunnel when passes through syncline, in such situation the tunnel is subjected to more lateral pressure in middle part. In this zone when we are going to create tunnel, then the middle part of the tunnel away from the opening. Here in anticline this portal part is more under the stress, lateral stress, feeling lateral stress. However, if the structure is a syncline, then the middle part is going to, this portion is going to affect by presence of syncline. As far as the lower portion of rock is concerned, sometimes this lower portion of rock is weak in nature. Therefore, the weak nature of rocks going to fall along with the flow of water going to create lot of water inside the tunnels, require dewatering. Involvement of pump and other to drain out water from this on one side. On another side, due to percolation of water from the surface, percolation of water from the surface is going to further weakening of this type of overlying rocks above the crown of tunnel. The presence of such folded structures and its merits needs to be identified during geological investigation at the planning stage of tunnel for necessary drainage arrangement in the design. Otherwise, the tunnel may be under tremendous problem if excavated in syncline type of fold. In another case, if we are going to shift this tunnel towards the vortex zone of anticline or trough zone of syncline, then the vortex part of the anticline and trough part of the synclines behaving similarly. Here lot of interfaces or joints going to make this portion weaker in nature. Therefore, we generally going to avoid about the construction of tunnel in this zone. Construction of tunnel in this zone and in this zone. Next, common type of structure generally associated with sedimentary rock, as well as if we are going to consider foliation, lineation, schistosity as a similar type of linear discontinuity, then the schistosity and foliations and lineations are also playing same role as we are going to observe in case of bedded rocks or the beddings. If the tunnel passes through bedded rocks with unfavorable strike and dips and structures involved in fold faults and may lead in instability of tunnels if located close to hill slope. For example, a dipping bed toward the lower valley if traversed by tunnel at right angle is likely to be affected by the slope instability problem. In case of horizontal or vertical bed, there may be not any such serious problem if the tunnel lining is aligned parallel to it. However, if the strata or fault plane dips toward the slope or the folded rock with axial dips in incline toward the slope, it may lead to the problem of slide, especially after saturation with water if going to interact with surface water. Here you can see the different situations we are going to elaborate. Effect of bedded rocks on tunnel lining in general. If the beddings are almost horizontal, this geotechnical evaluation of rock condition at depth and predicted rock pressure on tunnel heading are very important at the planning stage for consideration of data in design of structure. If the tunnels traversed by a horizontal or low dipping bed, then in such cases a tunnel passing through horizontal or low dipping bed, there may be uniform vertical pressure on tunnel lining. If the tunnels passes through the vertical type of beds, this type of beds, and the tunnel lining perpendicular to the strike of bed Here is strike up bed, this is dip up bed, and the tunnel axis perpendicular to, this is the tunnel axis, perpendicular to the strike, this is the strike. Then the tunneling will also experience uniform vertical pressure and require typical strong support. If the tunnel alignment is parallel to the strike of vertically dipping strata, then there may be heavy pressure on this arch zone. And friends, you know, the arch is going to distribute load on this wall side. If this arch is feeling heavy load due to presence of such structures, then the wall should be strong, otherwise there may be problem of collapse of created tunnels. If the tunnel axis is perpendicular to the strike of dipping strata, you can see this tunnel axis. Tunnel axis is a perpendicular to this type of obliquely dipping strata. Then in such situation, the lining will experience uniform vertical pressure with longitudinal thrust. There may be shifting of this whole strata because at 45 degree of dipping, the strata is showing weakest nature as per geomechanical perspective, and in such situations there may be slide of this strata if there is a percolation of water or change in conditions due to temperature difference, etc. The tunnel aligned parallel to strike of dipping bed. Here the tunnel is a parallel to strike of dipping bed. This is the strike of dipping bed. The bed is in dipping nature. Then in such situation there will be pressure concentration on the sides of tunnel lining. Here the sides of tunnel lining is going to feel or experience typical problem of pressure or stress concentration, may create lot of instability problem or ground control problem. However, the tunnel axis is oblique to the strike and dip of inclined bed, then what happens? The pressure will be concentrated on the sides. The sides are feeling higher stress condition and may create some bulging in this zone and responsible for the movement of detached material from the walls inside the tunnels. The tunnel aligned perpendicular to strike of sedimentary bed is comparatively a better situation than that aligned parallel or oblique to it due to strength response of such rock strata containing bedding of such nature. The stratified and foliated rock may also act unfavorably, similar to the bedding, on tunnel lining depending upon the relations of foliation dips and strike with the tunnel axis, similar to the bedding. And if the tunnel is aligned oblique to strike of the foliation, a situation may arise where the main thrust will be on the side, resulting in overbreak or partial collapse of the side wall and ultimately going to show about the failure of whole created tunnel structure. Next type of problem is associated with joint, and friends, you know, the joint is playing very important role in strength estimation of rock mass or rock strata. Therefore, on one side the presence of joints is going to weaken the rock strata, creating lot of ground control problem in tunnels. On another side, the higher frequency of joints is leading to overbreak problem during excavation of tunnels. The overbreak problem is a critical problem which going to disturb or deteriorate the design profile of opening. Due to this, there is a requirement of filling material as a lining and the costly support system as well as some filling materials make the situation complicated from ground control aspects. Therefore, to avoid this type of problem, generally we prefer to construct tunnels at higher depth in case of jointed rock, because the frequency of joint is gradually reduced in nature with respect to depth. On another side, the thickness of rock cover is an important criteria in geological analysis concerned to the stability of tunnel or ground control aspects of tunnel. When the rock cover is sufficient, it directly going to make some lithospheric load on tunnel crown. If the cover is not thick, then there is a problem of seepage, percolation and draining of excavated tunnels are going to puncture the groundwater table and create a lot of problems. And if the strata is very thick, then going to create problem in view of enhanced lithospheric pressure on this. So the design related to rock cover are overburden as well as the different characteristic of joints like spacing, like frequency, like fillings, like apertures, etc. is going to influence on the performance of drill and blast assisted excavation of underground opening or tunnels. The effect of joints principally depends on the strike and dip of joint. In dip, the direction and amount of dip both going to influence the ground control aspects of tunnel, either in form of overbreaks, either in form of instability. So, the inclination of joints or stratified rocks are affecting the ground control aspects of tunnel, as in horizontal strata traversed by inclined joint, the overbreak may be up to half of the tunnel diameter, therefore required to considered in design aspect. In vertical strata with horizontal joint, the overbreak is restricted to 1/4 of the tunnel diameter. This point should be incorporated during the planning and design of tunnels. In case of the inclined strata traversed by joint at any angle, the caving in rock strata is restricted to maximum thickness of half of the tunnel diameter, because this situation is problematic in ground control aspects of tunnel. However, in highly jointed or crushed rock, the overbreak may extend up to 3 times the diameter or 3 times the sum of height and width of tunnels, creating lot of problems and require some primary treatment before drill and blast if situation permits. And next, it is also noticed that the pulses due to blasting are not transmitted beyond the distance of twice of the tunnel diameter, that also additionally creating lot of vibrational impact, and this vibrational impact is going to create lot of ground control problems, because the rock strata is showing reduced strength in cyclic type of stressing in comparison to normal compressive or shear stressing. Therefore, during the vibrational type of impact caused by movement of mechanical waves generated during blasting or detonation of the explosive or explosive detonations induced propagation of mechanical waves, creating lot of problems concerned to ground control problem by weakening of rock strata. Next important feature is a fault, and the fault is going to influence tunnel stability or tunnel aspects related to ground control depending on the location and characteristic of faults. In general, you can see here, due to this what happens, the material present in fault zone is going to create lot of problem by squeezing or falling inside this tunnel, because the material available in fault zones are weak in nature and not able to support the created opening during the redistribution of stresses and resulting movement of the rocks of fault zone inside the tunnels. In this way, going to create problem. In particular situation, when tunnel is in the hanging wall of a fault, you can see here the tunnel is located, this is the fault, this is the footwall, and this above this is the hanging wall. If the tunnel is located in hanging wall side, the fault is subjected to offshoots of the fault, and if it is a reverse fault like this, the hanging wall block containing the tunnels move, and which is unfavorable and very critical problem in ground control aspects of tunnels. Next situation, when the tunnel in footwall, earlier the tunnel was in hanging wall. So now if we are going to excavate tunnels in footwall, this is the fault plane, this is the hanging wall, this is the footwall. In a normal fault, the footwall block is subjected to movement, and this position at the footwall block is the worst scenario for the tunnel driving and creating serious ground control problems. Due to such situations, the tunnels are not favorably recommended for such situation. If necessary, then proper treatments and support systems should be inspected and observed carefully. Tunnel alignment traverse perpendicular to the trend of fault in this way. Then in such situation, the zone of intersection of tunnels and faults are generally called ground control problem. This material is going to fall inside this, and in this way going to create lot of problems. Moreover, this condition is better than the tunnel lying oblique to fault in previous situation. And the tunnel traverse oblique to the fault, here you can see this tunnel axis oblique to the fault, two tunnels traversed by two faults. In such kinds of situations, the tunnels are encounter either thicker zone of crust rock, which is leading to fall inside the opening. Thus, it is necessary to take the tunnel through the position where the width of the fault zone is of minimum thickness, even by giving a kink to the tunnel alignments. It means, if not possible to avoid the tunnel thick zones, then we have to create some shift, or we have to shift tunnels slightly away from the main plant tunnels, so that such type of adverse rockfall and filling of material inside the tunnels can be avoided. Another very critical problem when we are going to drive tunnels in active faults. As the name indicates, active fault is still active in nature, lot of movement, lot of changes in extension of fault zones are going on. Therefore, in such situation, if the tunnel traversed through an active fault is posing very serious ground control problem due to active nature of faults. Such type of faults we generally encounter in case of the Himalayan tunnels. Therefore, an alignment for the tunnel should not be run along the fault zone, because there is lot of changes going on in fault anatomy, as well as the different features related to thickness, related to extension of fault zones, related to change in strikes and deeps, or development some new faults and others, branching of the faults, creating lot of problem in such situation. So a serious damage to a lining occur when the tunnel cuts the fault, and there is experience of fall of crust rock masses and goo fault inside the tunnel and going to block the whole tunnels. Due to this, there is a loss of money and delayed in time, and still there is chances of uncertainty in view of ground control problem. In situation when the tunnel passes through a low angle fault thrust, this situation is the most damaging features of the tunnel, and the presence of water flowing through the fault zones might cause overbreak and even collapse of the tunnel. The draining of water inside the tunnel is a very critical problem, very acute problem. When this flow of water is containing the weak materials is also an additional problem, because the water is going to reduce the strength of rock strata. So in this way, this type of low angle thrust fault is very problematic. Active fault traversing a tunnel, then the reactivation causes immense destruction, and this crushed material of fault zone may flow out and deposit in sandy material on the tunnel force, hindering tunnel progress and creating lot of problems. Therefore, mitigation should be necessary in such situations. The shifting the tunnel alignment or selecting an alternative alignment away from the fault save potential hazards, because such type of problems cannot be avoided due to active nature of faults, and the active nature of faults is also liable to some seismic activities which are going to further damage the created opening, and the ingress of water inside the tunnel also very problematic. So therefore, as possible as to avoid the locations of tunnels near from the active tunnels. Friends, this material I have prepared from the book Engineering Geology, written by Gangopadhyay, published by Oxford University Publication page 12549. Then partial supports from the book written by F.G. Well in 2007, named as Engineering Geology, having page 12551, and then partial supports from the book of textbook of Engineering Geology written by Kaushabulu NC, ranging in page 12495, and then some aspect taken from the Shiva Bharati Murti regarding the Engineering Geology Unit 4, page 4 to 33, and about some tunnels related to the traffic tunnels. We have taken some help from the Amber W and the Lombardi G written paper in 1982 on the Swiss National Committee on large dams and roads. Friends, today we have discussed about beddings, fold, faults and joints are affecting the ground control status of tunnel. The strike and dips of bedding, fold limbs, lineations, foliations are causing ground control problem is depending on the position of tunnels with respect to strike and dip of such features, linear features. Both anticline and syncline pose enhanced stresses and percolation of water depending on the position of tunnels with respect to vortex or top part, vortex zone or hinge zone of folds and trough zone of syncline. Another structures like faults are problematic for ground control aspects because the fault zones are containing very weak and loose materials. Therefore, the tunnels traverse through the fault zone or nearby fault zones is feeling lot of ground control problems in form of filling of material from side to into the created opening. And the joints are problematic as it affects the strength of rock strata on one side, on another side it going to induce the overbreak, that is costly and time taking problems. And unconformities are also responsible for seepage and percolation of water and complicated ground control problem if the interface intersect the tunnels or come in way of tunnels. So in this way we are going to see about the effect of geological structures on ground control facets of tunnel. Dear friends, in this class we have elaborated about effect of geological structure, particularly beddings, fold, faults, joints, and in brief unconformity on ground control aspects of tunnel. Thank you very much.